Okay, usually the user might want to see the computed so far the best solution. So we will provide this kind of user interface for the user to see the computed so far the best solution and the objective value. So let me change it a little bit. Okay, so I will undock this chart. And so undock it and shrink it. So I kind of like to add another spread container. Spread container is in the category of container. So spread container. On the summaries, I like to change the orientation from vertical into horizontal. So the upper part will be used to display the best solution information, and the lower parts will be the chart. So remember that you need to add the title, okay, and beautify the grid line. Don't show it in bright color and same thickness. Alright, so reduct it again with respect to its parent. Okay, within this upper part, we might have a label display. So I like the label to be dark to the top, and set auto size to be false. And make the alignment, text alignment should be the middle top. Okay, and I also add a rich text box, because the contents of the basic solution might be very large, so it is better that I use list box. I use rich text box to display it. So similarly, I can set the dark property in the field. Alright, so because programmatically we need to access it, so label so far the best, right? And this one should be the rich text box. Maybe I simply call it the best solution. Okay, so we need to access both control, right? So for this control, we set its modifier. No, there's only modifier here. Right here. Supposed to have been to be public, because these controls are dedicated for our GS server, so you can say that. And finally, I tag the spread container into the host space. Alright, so that's what we want, right? Okay, so initially I should set the label maxima into okay, then I select alright. So remember that you needed to set the inevitability. So firstly, we just have a reset button enabled, and once reset is quick, then normal iteration run to end will be enabled after that. Okay, we have done with this. So let us go back to GA, right? So in our generic GA solver, once we evaluate the update so far the best solution, right? If so far the best is updated in this iteration, update labels and the solution, update objective label. Okay, so you need to add the condition here, but right here I am just like to add it directory. So monitor dot lab, so the best objective text equal the best objective value, right? And it's pretty simple because right now in our GA solver we have that value updated, so that should be the so far the best objective value. And if you can specify the format, probably we like to show it up to 4 decimal places. So that's it. And we need to rewrite the solution, right? So usually you can say rich text the monitor, which text box solution text equal what? Initial 0, right? So you kindly loop through each item of the basic solution. So usually you will say, well, probably for each type in best, so far the best solution. And then you kind of aggregate the text, right? So you might think about this one, plus add, and then use formatted string. So that should be the I. Instead of common there, it's okay. But it is not good at all because right now you keep using string concatenation, which is really memory consuming. So usually we are not doing the string concatenation right here. Why? The reason why, I will show you why. Because the string, it's a string, right? String by default is a reference type in C# programming language. So sometimes we have this kind of statement. For example, suppose right now so suppose in your code we have a string s initially should be equal 0, right? And then you kind of loop through for int I equals 0 and I plus greater than 1000. I don't know. Maybe the counter is very large, so each time you kind of concatenate, use this statement, or probably use this way. Original s concatenated with string constant. So you put the I there, and then maybe with another comment there. So you kind of loop through this concatenation statement for maybe 1000 times, and it will be memory consuming, right? Why? Because string by default is a reference type. So what actually happens is that, like here, so since you have a local variable s, right? So s is a reference type. So initially, behind the C# programming, there is a variable we might call it s. So s is a reference type, and then initially, since it's a non-string, so there is non-string. This is a heap. Right now, it's a heap memory. So since you have a non-string, right? But in fact, non-string do have string allocated without any character specified. Well, it's a empty string. So suppose the address initially is if the initial memory is maybe let me see. Probably the memory is 11. Whoops. If the memory in the heap is 11, then currently you will have 11, the reference assigned to S. So initially, in this case, so your reference refer to this string. This is a number string. So S equal number string. In the first iteration, so right now, number string, try to add a string 0 and a comma, right? So once we add it in the right hand side, we have another string concatenated with 0 comma. So you will have a string allocated on the heap. That should be another string concatenated with 0 comma blank space. So the computer will generate another string. This is another string. So suppose string address is 30 maybe let me call it 22. So once you finish this S equal S concatenated with 0 comma string, then what do you get is right here. So US has been overwritten by the computer. So right now your string is 0 comma and a space bar. So in the second one, we use this value, right? So in that case, we will use 0 comma blank space. Try to concatenate it with 1 comma blank space, right? So the result in the right hand side should be a string 0 comma blank space 1 comma blank space. So in the right hand side, we will have a new string generated. So memory will be reallocated again. But so by this time, the string is 0 comma 1 comma and space allocated. So once this memory is allocated, the address, suppose this address is 33, will be reassigned to your S. So right now S value is the reference value is actually 3. So the current string is 0 comma 1 comma. So as you can see, during this 1000 looping statement, the memory has been allocated for 1000 times. So it keeps using up the memory. The problem is that because the string is a reference type, so each time user try to change something, but actually, in fact, memory has been allocated quite a lot. So finally, you will get a length string. So your S right now is pointing to a very length string. So as you can see, it should be very careful if you have repeatedly add a string to a string, which is really memory use. You will use up a lot of memory. So usually in this situation, we are not going to let this happen. You need to carefully, save your memory. So we are not going to use this concatenation operator for our string operation concatenation. So then how can you do that? So usually in this case, we will ask help from another class. This class called string builder. So I might call it local variable name, and then we new this object first, string builder. So once we have it, then initially you can use clear. So actually this string builder, well, what a string builder actually working is that a string builder will prepare a fixed size of memories in its object. So there is a fixed size or a chunk of memory has been allocated. So once you repeatedly add anything there, so the string builder will use its memory, try to keep 0, +1, comma 2, comma 3, and probably up to its memory its memory limit. So up to this point probably should be 129, for example. And if the memory is not enough, the string builder will allocate another chunk of memory. So keep concatenate your string. So comma 130, 131. So only one copy of your final string will use up the memory. So this is the right way we concatenate the string repeatedly. So usually we'll ask help from the string builder. So string builder clean up all its buffer, and then we simply just ask the string builder appended text, appended lines. Okay, because it's just elements. So we use this string builder to concatenate this substring to the final string. So that is the way we do it. So and finally, if you want to write the concatenated string to your label, so we directly set our text equal sb to string. So this is the correct way that you concatenate a lot of substring. So this way we ask help from string builder to do this job for us. All right, so after we update the software and the basic solution, so you need to check this condition. If so far the best is updated, then we update our label and the basic solution. Okay, so definitely this should be available. So currently I'll just simply set it true. So you need to check the condition and then execute this code once your software and the basic solution is updated. Okay, so we can see the result. So up to this point, we kind of update our monitor to okay, this is software and the basic solution, right? So run again, because we did not do anything. So this is the best objective value. Wow, excuse me, best objective value is not updated, right? So on the best objective text. Let's double right. Why there is no any value came out? Oh, I'm sorry, because it put into the next line, I think. Best objective is software and the best objective. Interesting. Okay. Suppose bigger. Oh, okay. And a mistake, right? The base objective value is quite large, so yeah, it's since our problem is maximization, so it is minimize values over double. Okay. Anyway, you need to update the solution by yourself. So the objective value by yourself. Okay, so I'm here simply make it a fix to show you how to do that. All right, so 999, it's fixed value. So run one iteration. So once your software and the basic solution is updated, so solution will be updated right here, and the objective value will be updated right here. All right, so now we're completed the GA execution monitor right here. But remember that you need to populate the property for the user and carefully set the categories and specify the specification for your user, add access title, beautify your data grid, your chart grid somehow, and then set up the inheritability by yourself. Okay, that is for the update of our GA monitor. So again, since the GA monitor is probably not required by the user, so we are going to add this code. Simply check the whether so far the best solution are there. So actually, in fact, you need to check if the monitor not equal none, and so far the best solution is updated, something like that. Okay, right. All right, so similarly, since we have added the our label, right, and also the some of the business solution, so you need to add something to the reset. You see, during the reset, we reallocate the memory, and also if the monitor is not known, that means the user like to see the progress of the GA evolution. So here we need to clean up the solution. So the monitor.label, so the best text equal, so the best objectivity, right? I cannot remember exactly the content. So add it, and also we clean up the rich text box, the monitor rich text box, the best solution clear. So resume everything. So if the user click the reset button, so during the GA reset, if the monitor is used, then we need to clean up everything. All right. Okay, so before we proceed with the Java assignment problem, let me show you the C# programming languages, some feature you should know about that. So let me use the program file. This is the entrance function, main function, right, for our project. So I kind of use here to show you something. Remember that we have been using the array, right, to sort the array. So here I like to show you an example. If I have an int array and it's an array, so maybe it's int, so probably is ii equal 9. So it's int value, and then in this way it's an I array. So it's I array, and if it is I array, it's a reference type, but II is a value type. int IARY is an array. So suppose it's an array, I kind of maybe I need to use random number generator to generate. Fine. So I kind of new int maybe 30. Okay. And then I have double fitness value. So similarly, new double 30. And then probably we have random number RND, random number generate. So I kind of go int I start from 0 I up to not 30, probably just 21 I plus plus. So I array I equal I. Well, maybe just fine, just 21. So fit I next double. Time 100 minus 50. Okay, so we have random number there. So in that case, we ask help from array. Sort. So we choose this one. We think it should be the this one. 5017. So excuse me, not this one. There should be this one key. The first one should be key. So we will use the value of the in the fit arrays and sort both array, including the keys, including the fit array and the ARY array. And start from 0 up to 21. So what really happened there? And then we also apply array, right? Inverse, reverse. Simply work on ARY. Or probably you can reverse your fitness value. It's okay, but it's not necessary. So let us quickly see what will happen. That means, so you need to get used to this sort function to know what exactly you are doing. So up to this point, you check your code. This is the local variable, right? Local variable. So as you can see, how many local variable has been declared in main function? We have II is a value type. Since integer int is a value type, so there is the value contained within this memory is actually its value. But start from array, array, fit is they are both of them are array. So array are reference type. Ind is an object. Object is a reference type too. So ind is a noun. Currently is a noun. So the whole idea is that right now in our main function, it will use up so-called stack memory. So suppose these are the memory, and here this main is executing, so we call it stack. Another one is called heap memory. Heap memory will be allocated dynamically, and by stack memory will be repeatedly used by function call, and it is stack. Since it's stack, so the first come, that's the leave. So in this case, right now we have three variables. So II is right here. This is II, IARY, fit, and IND. So up to this point, this memory is used up. This memory has been used by main function. If main function call another function, the other function will use up the rest of the stack memory. So currently it's here. And if you look into the memory content, it's II, this is II, this is IARY, this one is fit, this one is RND. So initially the reference type none, NULL, but for I is 0, current is 0. So once this line is executed line by line, so let us run by line. '99 is assigned right here. Okay, and then we are about to execute this line. So 30 int will be allocated on heap. All right, so in that case, the computer will allocate, the memory will allocate 30 ing. So memory 30 int memory space will be allocated, and if the initial address is maybe 77, so right now the 77 will be right to the fit. So right now fit, excuse me, IARY 30 int. So IARY right now is 77. So IARY pointed to this array. So this one should be IARY0. IAR11, IAR12, IAR up to IARY29. So actual value will be kept or will be stored in this heap memory. But IARY is a reference type, so it simply store the address for that heap. So similarly, if we execute this line, new double 30s, right? Okay, so the memory will be allocated for this fit array. So another 30 double value. It's a 30 double typed data will be allocated consecutively in a heap. So if the starting address is probably 1, 2, 3, 4, so 1, 2, 3, 4 is address that should be pointed to here. So that means this is the fit zeros up to fit 29. So that is the memory allocation going there. And we are about to execute this line. So once we allocate, run this line, it depends on the memory usage of random class. So similarly, the computer will allocate another memory here. Suppose this part of memory is for a random class, INDOM. So we don't know exactly how many bytes will be used up by an object of random. Does not matter. So if the starting address right now is probably 1564, so it will keep 1564 pointed to this data. So that is the type, so-called reference type. Reference type actually is, you can regard it as a C programming language pointer. So they simply are pointed. All right. So that is the ideas about the mechanism that memory allocate dynamically allocated by the computer. So up to this point, we looked through only 21s, right? So we keep assigned data. So let me go through up to this line. So right now we have IArray. Keep the index, right? Sequentially up to 20s, starting from zeros, right? And how about the fit array? So fit array is an arbitrary value, right? So some of them are negative, some of them are positive. All right, so again, up to 20. So now we ask the this array sort function to sort these two arrays for us, but starting from zeros up to 21st. So based on the value stored in the fit. So once we run this code, let us check about the fit. So fit right now, starting from the lowest value, minus 46, up to the largest one, 46. And during the sorting, the IArray is associatedly sorted. So right now IArray indicated the indexes, the initial index of that fit value, right? So 3, 4. So right now the array 3, the index 3 is originally is the smallest value, right? So so we keep that index right here. But because we need to sort our fitness from the largest to the lowest, right? So we invoke this this function reverse. So after reverse, IARI will change that, right? But as you can see, the 0 always start from there. It's not right, right? So you need to carefully use the reverse. And how about the fitness? Fitness also reverse in this way. So it is not right. We simply want to reverse the first 21 element. So it's not what we want. So again, if you check it, the reverse function, as you can see, there is a similar function that starts from 0 up to 21st. So you need to always supply this kind of extra information. Tell the array class that you are not going to show the full array. Simply start from 0 up to 20th element. Okay, so you should be careful for this kind of setting. And probably even those we compute up to 20th, probably what you need probably just want to solve the first probably first 15th. So in that case, you should do it carefully in that way. Okay. So up to this point. So I array in this way. So we keep the index up to 20th, right? Fitness value randomly given from 0 up to 20th. And then we sort only the first 15 element only, right? So after the sort, let's check our fitness. Fitness right now starting from the lowest one up to the last one in 14th, right? Because the 15 element will be sorted, right? So it's up to the 14th right here. So we did not ask the array to sort the rest of the element for us, right? So probably this is not required, right? And how about the IArray? IArray also sorted according to the value of 15 there, but not for the 15, 16, 17, 18, right? We didn't ask for that. So later on, you need to reverse the value of the fitness value, right? And also you need to reverse the index array. So from 0 up to 15. So in that case, your fitness array right now is starting from the largest one up to the smallest one up to 14th. Up to 14th. 14th. So your I array then is the best should be so right now UI array, this is the best. Well, in your case that should be a chromosome ID, second best, third best, right, up to here. So we did not show that for starting from 15, right? So these parts remain there without any sorting. So after that, probably your population needed to select. If it is a deterministic selection, probably you just select the first 10th chromosome into the next generation. Alright, that's the way we use the so-called indices array to help us determine anything. But this is simple. This is for what? For deterministic selection. So it's very simple. Just once you get the fitness value and then you prepare the index array, then you will find out who is the best. But you need to pay attention to that. Sort is by default sort the values starting from the smallest one up to the largest one. So you need to flip it over. You need to use the reverse function to change the order of the fitness values and your indices. Okay. Okay, for stochastic selection, so probably you have your fitness array computed, right? So you might have a fitness array. So let me use an example to show you how to perform the so-called stochastic selection. So fit is a double array, right? So if we have an array fit, right here. And the first value might be 3, 10, 1, 2, 8. Another one probably 4. Okay. So right now your fitness have 2, 4, 6 elements. So suppose you ask to stochastically select 4 element from this fitness. So remember that the index is right here. The index right here is 0, 1, 2, 3, 4, 5. So basically we have 6 chromosomes, and the fitness value has been computed from objective value right here. So right now it's about the time we stochastically select, for example, 3. We need to select 3 chromosomes into the next generation. So how can you do the stochastic selection? We call it a roulette wheel selection, right? So the idea is that the whole idea is that we set up a roulette wheel, right? So totally there should be 10, 20, 25, 28, right? 28 quotient. So 28, well, maybe it's okay, 28. So the idea is came up from, well, 28. This part is 3, right? 3, 28, okay. And then this part 10, 1, okay, and then 2, and then 8, and then 4. So ideally is that the roulette wheel, each chromosome receive a portion of probability, right? So usually if you insist on so-called probability, you need to, because totally that should be 28, right? So the probability should be 28, 3 over 28, right? So actually you don't need to calculate it. You don't need to normalize it as the probability. You can directly use this so-called relative probability to do that. So starting from 0, right? This is 0, zeros, 1s, 2, 3, 4, 5, right? So 0, 1, 2, 3, 4, 5. So totally they are 20. The total amount should be 28, right? 28, right? So it's very simple. If I can set up, this is the first threshold. This one should be the next threshold. That should be the third next. Excuse me, up to here. And then it should be the another one. So if I have this kind of information, I can easily stochastically select 3 chromosomes from this stochastic selection. So how can we do that? It's very simple, right? So we kind of add it up. We know the total is 28. So and then we update it. We added that to here. So starting from 0, 3. So right now it has been changed into 10 plus 3, 13. Right? What means 13? Here. 13, right? And 13, 1 plus 13 should be 14, right? So it's 14 right here. It's 14. It's a kind of threshold right here. Okay. So the first threshold is right here. 3, 13, 14, and then the next one is 16. 2 plus 14, 16. 8 plus 16, 24. So up to this place, 24. And then 24 plus 28. So that should be our limit, 28, right here up to here. So once you update this, so remember that fitness is, we don't need to always keep the original fitness value, right? So fitness is kind of scrap memory for us to do all kind of operation. So even originally we have a fitness series calculator and transform from objective value. But right now, since we are about to do the stochastic solution, so we reuse this fitness value, but add it up to the with the previous cumulative value. So we cannot set up this kind of threshold. All right, so 325. So right now you are about to select 3 chromosomes, right? So you will set up 3 random number, right? 3 random number. So you call random that next double, right? Double. So that double always start from 0 up to 1.0, right? So you calculate the next double and then you times it with the total value 28 times 28. So the value will be remain within this 0 up to 28.0, right? So each stochastic selection, you generate a random real number ranging start from 0 up to 1 and time 28. So actually your random number value start from 0 up to 28. So and then you kind of starting from the 0th one to see suppose the first random number after time 28 is 2.8. So 2.8. So 2.8 smaller than the first threshold, the 0th threshold, right? So you kind of choose 0th chromosome as your first survived chromosome. In the next row, after you get a random number, time 28, you might obtain maybe 10.5. So 10.5, right? 10.5. So you check whether it is greater than 0th or not. Yes, greater than 0th. And will it greater than the 0th? This is the first threshold. No. So since it is not greater than the first node, so that means you will select the first chromosome, right? So in the third stochastic solution, random number time 28, if the value may be up to 16.5, right? So you look through the zeros, greater than zeros, greater than first, greater than seconds, greater than the third, but not greater than the fourth, right? Because the fourth is 24. So in that case, you kind of select the fourth chromosome. So that is the way you take advantage of this fitness array to do the stochastic selection. You don't really need to prepare another probability data, and then computing the total sum and then convert that into a probability. No, you don't need to use any other data to do the stochastic selection. You simply focus on reusing the fitness value. So this one will put it into the indices 0, right? So index is 0, and the indices 1 is 1, index 2 is 4. So right now you choose chromosome ID 0, first and fourth as the selected chromosome into the next generation. But pay attention to that. If the solution mode is stochastic solution, so probably you will see, well, maybe similar, the same ID will appear more than one times. It's reasonable because it's the stochastic solution, because this probability for chromosome 1 is bigger, is larger than the rest of the chromosomes. So definitely the chromosome 1 might be multiple selected during this stochastic selection. So remember that if you want to implement the stochastic solution, you simply overuses this fitness array, and also you need to update the indices. Just like the stochastic selection, we store the selected index in this indices array. Okay, that is some guideline for stochastic solution. So let us go back to our original problems. Our problem is a job assignment problem, right? So you need to read in the file. So basically what you need is a read button, right? Or probably you like to add some menu strip. It's up to you, okay? So there's a menu and toolbar, so probably you can add a menu strip. Some. We undock this one and then grab undock. By default, if you drag in a menu strip to a container, it will dock to the top of that parent. So we undock it, and once you undock, can I see it? Right here. So then we dock that back. So either way, you can add a file and read. Doesn't matter. Actually, you can regard that as a button. So similarly, you can subscribe the quick event for it. But you need to prepare a dialog. It's an open file dialog. So initially, you can set up the property for this open dialog. So please take a look at the lab instruction. I mean, in assignment 6, when I talk about how to set your model and read your model. So you need help from this open file dialog to identify the file path. So once you have a file path, what you need to do is so you need to use dialog, right? So open file dialog. So you use this open show, and if the result is equal OK, or if it is not OK, then we will not do anything. All right. If not equal OK, we will return. Otherwise, the user specified file path has been stored within this dialog. So what you need is string reader. String reader. It is located within the IO namespace. So string reader, new open file dialog 1 file name. And once you read in everything, you need to close it. Okay, so a lot of property may be set up during your design phase. So take a look at the dialog. Go through each property, okay, to see what kind of property can be specified. All right. So when we read it, so you can SR. So usually we will invoke SR read line because it is a what? So we prepare a string str to read in a line, and then if it is string, probably so. If we look into the example we have, you can see during each line, probably your string is looking like this one, probably 2.3, 4.5, 1.2. 1.0, 4.5, 23.1, 246, 8. So probably what you read it in is a line right here, right? So probably in the job assignment bank, you might read in a line here, but you need to spread each item. And then you know each item should be converted into double. So in that case, we need the help from string class. So if you use the variable name string variable name dot, you can see a bunch of utility function is provided for you. So basically what you need to is a split function. Split function will return you a list of substring, right? So it's an array of substring. So if you invoke a split, you need to prepare a string array. I might call it items. So many overloaded function can be invoked for this split function. So the simplest one probably you just supply the character which will serve as the delimiter. For example, right now comma is a delimiter, right? So if you say that, well, comma is a delimiter, so you can put in there. Or probably another one is blank character, right? So blank character will be separate, and a comma will be separate. So you invoke this kind of statement. So then you will have items. So ideally, in this case, 1, 2, 3, 4, 5, 6, 7, 8. So ideally, the item should contain this 8 value, right? So later on, we will convert that into our setup time, something like that. But if you look into this example, so let me run it. So click on the button, and then file dialog show up. So let us navigate it to our library. So a job, right? A job application. So open it, and then we read in the first line, right? First line should be a 9, 8, telling you that you have a job. But right now, suppose if I read in the next line, str contain this kind of information. So I invoke this split function, and what items can be obtained? Look into it here. So this is original string. So it is hard to say that what kind of character has been specified within this file. So probably I don't have a blank space. I might have multiple blank space. I might have, well, because basically these data are separated by comma, right? But probably user may have added more than one blank character. So what will happen after this split? So initially 2, 3, 4, 5, 6, 7, 8. So we expected there should be 8 items, right? So, but you can see what you get is 16 items. Why? 2.3, okay, it's fine. But how about the second one? Second one is a non-string. So non-string is still recognized. Why? Because we say that, well, if user if the computer bump into this character, comma character, it serves as the delimiter, and also comma, right? So right now we have a comma, and also we have a blank space. So within these two characters, there is a non-string. So non-string will be regarded as element. So this split function does not serve our need. So what you need to do is you need to invoke another split function. So basically what we want to invoke is this function, this operator function. So we like to specify string split options. So we need to set this one, but you need to have a character array. All right, so, well, we may prepare this character array first. I might call it separates. And then you say that, well, comma is used as a delimiter, and then blank space 2, right? All right, so we have separator ready for us. So then we can invoke this split function, and then put, we like to invoke this function, separate. So seps, not this one, I'm sorry. We need to specify this option, string split option. So we can type ssp o dot remove empty entries. So as you can see, in previous case we have an empty string, right? So we invoke this option, so we will have clean items. We will have a clean substring array resulted from this split function. Okay, so if a string is here, then we set a separator, and we invoke this split. All right, so you can see all 8 element has been subtracted from this string. So right now item 0. So now you need to loop through these 8 items and then convert each item, because it's a substring, convert that into double type. So that value will serve as your setup time. Okay. And another important thing is that in your main phone currently is we have prepared objective function, right? We have prepared a simple objective function. So if you are dealing with the job assignment problem, for example, you might know, well, when you first read in the string, so definitely you will know int number of jobs, right? So the first line should be the number of jobs. So you will ask int convert. No, not parser. That should be a string, str. Fine. And assign that to number of job. So you know the number of job somehow from the first line. And then you loop through. Anyway, you need to complete this part by yourself. I'm not going to do that for you. Okay, so right now you have a number of job, right? So how can you define the objective function? Okay, simple objective function. Maybe like to change the name for our job assignment. So I might say job fine. It's up to you. So job assignment problem, objective function. So right now you get a solution prepared by the GA for you. So you need to tell the GA what is the objective value for this function. So as you can see, if you look into the instruction, well, actually, since we have been using 0, 1 variable, so we will have an extra constraint. So we kind of dealing with those constraints by using the penalty value there. But it's troublesome for us because solution is a one-dimensional array. So probably you might think, oh, okay, I need to count the row amount, column amount. So you keep it declaring, well, I might have an int array saying row violation counts and then new int number of jobs, right? Well, it's reasonable. Another array column violation counts new int number of job, and also you like to convert this one-dimensional solution into two-dimensional array. So you have byte two-dimensional array solution matrix new byte numbers of job by numbers of job. All right. Okay. What's wrong? You use new statement within this function. This function will be repeatedly called by GA solver. So it will use up all your memory. But if you need it, just as I say, you need to do it once, not repeatedly new this memory. So actually, you don't need to have this array. It's wasteful. But if you like to have this array to save your life, anyway, in order to compute the violation amount, fine. But don't do the new statement within this function. Because this function will repeatedly called by the GA solver. So how can you do that? Well, move this required data by yourself out, move it out to your class, your main function class. All right. So when will you instantiate memory for that? Definitely, it should be done once you button read in the number of job here. Do the memory allocation once, only once. Okay. It's very important that you do not use new statement within a function. That function will be repeatedly called during the meta-heuristic algorithm. All right. If you, well, actually, you really don't need to have this matrix at all. But as I say, if that will save your life, then you do it. But just allocate memory just once here. All right. That's the that is the one things that I want to remind you. Okay, so pretty much that will be all for the instruction of the assignment 7. So good luck.